Hello, you're watching section 9.5, Combinations. A combination is an arrangement or list of objects where the order is not important. Okay, yesterday we did permutations where the order was important. Combinations are when you're just picking a group. Okay, we're not talking about first, second, and third place and running a race. You're not talking about who gets to bowl first or second or third. We're just speaking strictly of a group of people. So later on, you're going to have to be able to pick out whether it's a permutation or a combination. So you're going to be able to read and tell whether the information is important, that it's in order, or if it's not in order. Okay, and as we read through these, hopefully you'll begin to make some connections on why they are combinations and not permutations. So if you look at this example, it says if I pick 5 people to sing a song, the order in which I pick those 5 people does not matter. Okay? An example of a permutation which would show, for example, how singing a song or 5 people would sing a song would show that order is important would be if there were 5 solos, the order in which they sing those 5 solos, that would be important. But if I'm just having 5 people sing a song, it doesn't matter in what order I stand them. They're all doing the exact same thing. First, second, third, fourth, and fifth is not important. Okay, so we're looking for things that are not important, and this is an example of when those 5 people, in order in which I pick those 5 people, is not important. Okay, so let's begin to look at some problems where we can maybe see a little bit more connections to show why the order is not important in a combination. So our first problem, Ada can select from 7 paint colors for her room. She wants to choose 2 colors to paint stripes on her walls. How many different pairs of colors can she choose? Okay, so she has 7 paint colors to choose from. So that's important here. Okay, but she's only choosing 2 of them. Now, why this is not important. If I'm painting stripes in 2 different colors, okay, is it going to look the same if the first stripe is red and the second stripe is blue? Or the first stripe is blue and the second stripe is red? Yes, the room's going to look the same. Okay, doesn't matter in what order I paint the stripes, it's still going to be, that room is still going to be in those exact same colors. Okay, so this is why order is not important. All right, so this is why this is a combination. How many different pairs of colors can she choose? That's the question being asked. Okay, one way is to make a list, which I find this to be take a little while, but if you are choosing from 7 colors, we can say red, yellow, green, blue, purple, orange, 1, 2, 3, 4, 5, 6. Red, yellow, green, blue, purple, orange. What am I missing? I don't want to. Indigo. So I don't have to have a different number or a different letter. So you can just start picking them. So I can have red and yellow. I'm not going to put yellow and red because that's the same thing. Red and green, red and blue, red and purple, red and orange, and red and indigo. Okay, then I could do yellow. Well, I already have yellow and red, so then I could do yellow and green, yellow and blue, oops, yellow and purple, yellow and orange, yellow and indigo. Okay, then I'm going to start with green. Well, I already have green and yellow, and I already have red and green. So I'm going to say green and blue, green and purple, green and orange, green and indigo. Then I'll start with blue. Well, I already have blue here, here, and here, so I don't need to have those same combinations. So I'm going to say blue and purple, blue and orange, blue and indigo. Okay, then I'm going to move to purple. I already have purple and blue, purple and green, purple and yellow, and purple and red. So I'm going to say purple and orange, purple and indigo. Okay, and then I'm going to start with orange. Well, I already have orange matched up with all those other letters, so I'm going to just do orange and indigo. And I have indigo matched up with all of these, so I don't need to go any further. Okay, so the different combinations I have can be found by just counting them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 different combinations of paint colors. Okay, now I'm going to show you a way that would also answer the same question. Okay, but would do it in a slightly different way. So what I'm doing is I'm choosing 2 paint colors. So you choose 2 from 7. Okay, so I have, and it's kind of like a permutation, 7 to choose from for the first color, 6 to choose from the second color. But different from a permutation is I'm going to remove the numbers that I do not need. Okay, and so since I'm choosing 2, I'm going to divide by 2 factorial. Okay, so this is finding, the top number is finding the permutation of the situation. So choosing 2 colors from 7. But the combination, since I know that's not important, the bottom part is then removed. Okay, so since I'm choosing 2, I'm going to take out 2 factorial. If I was choosing 3, then I would bring this out one more and then divide by 3 factorial. Okay, so you're going to divide by the number of numbers that you're choosing factorial. Now we know 2 factorial is the same as 2 times 1. So when I do this problem, I know 7 times 6 is 42. 2 times 1 is 2. When I divide, I also get 21. So 21 different combinations. Okay, so once again, the top comes from taking the permutation of the situation. I have 7 to choose from for the first color, 6 to choose from the second color. But because it's a combination, order is not important. I divide by what I'm choosing, the 2 factorial. So 2 times 1. Okay, so let's look at the next problem. How many different 3-topping pizzas are possible? Toppings are pepperoni, ham, sausage, green peppers, onions, mushrooms, and anchovies. So I am choosing 3 toppings. So I'm going to choose 3 from a total, and I'm just going to count, of 1, 2, 3, 4, 5, 6, and 7. Choosing 3 toppings from a total of 7. Okay, so I'm going to do the permutation of the situation first. So if order wasn't important, I would have 7 to choose from the first topping. So this is my first topping. I would have 6 to choose from the second topping, and 5 to choose from the third topping. Okay, this is assuming that you are not getting triple cheese. There's no such thing as that. That each topping is only used once on the pizza. Okay, so I have 7, 6, 5, and I only go down 3 because I'm choosing 3. And then I'm going to divide by the 3 factorial. Okay, because the number that you're choosing, 3 toppings, goes in the bottom factorial. The top, once again, represents what you have to choose from. So I have 7 to choose from the first, 6 to choose from the second, and 5 to choose from the third. Okay, just to remind you, 3 factorial means 3 times 2 times 1. So I'm going to plug these into my calculator, and I know 7 times 6 is 42, times 5 is going to be 210. Okay, then I'm going to take 3 times 2 times 1. Well, 3 times 2 is 6, times 1 is 6 as well. So 210 divided by 6 is 35. So you have 35 different types of pizzas that you could create given those toppings. So you have 35 different combinations of pizza. Okay, looking at the next one. 10 managers attend a business meeting. Each person exchanges names with each other person once. How many introductions will there be? So I want you to think about what an introduction is. Okay, if I introduce myself to Mr. Collinger, it is the same interaction as it would be if he introduced himself to me. So that's why the order is not important. The order in which we're introducing ourselves to each other is not important. Okay, I would be offended if I introduced myself to him and then 10 minutes later he came back up and introduced himself to me. Okay, that's not how an introduction works. So the order is not important. Okay, this is talking about 10 managers, but when you do an introduction, it's only between two people. So you're going to choose 2 from 10 because the interaction would only be between the 2. Okay? So the top number will be 10 times 9. So you have 10 people to choose from for the first person and 9 people to choose from the second. You're not going to introduce yourself to yourself. It doesn't make any sense. And so since it's between 2 people, I'm choosing out of 2. So it's going to be 2 factorial. Okay, which means 2 times 1. So I have 10 times 9, which is 90. I know 2 times 1 is 2, and then 90 divided by 2 is 45. So I have 45 different combinations. It's a lot of introductions, okay, between a lot of people. Okay, so there's going to be 45 different combinations of introductions that are going to be happening between these 10 managers. Okay, introductions only happening between 2 people. They're shaking hands, they're introducing themselves to each other. Okay, and the last one. If the introductions in the last example are made at random, what is the probability that Mr. Apple and Mrs. Zimmer will be the last managers to exchange names? Okay, so we're kind of thinking of a list. Okay, you're thinking of a list. And within that list, we know that there are how many different outcomes. So we just saw that there's going to be 45 different interactions. Okay, how many times will Mr. Apple introduce himself to Mrs. Zimmer? Okay, and I want you to think about this. If Mr. Apple introduces himself to Mrs. Zimmer, how many times is that going to happen if I made a whole list? Well, it's only going to happen once because it's a combination. Okay, Mrs. Zimmer's not going to have to introduce herself to Mr. Apple. It's happening at the same time. So there's going to be one interaction between these people, and so it would be 1 out of 45, the chance that they would be the last managers to exchange names. Okay, and that's this section. So I want you to, if you get stuck, reread this section by yourself. Okay, watch the podcast again. If you need to watch this and then listen to Mr. Klinger or I explain this to you tomorrow, that's fine. Okay, that's fine. This is a harder section, especially going from permutations to combinations, because they, for some people, are seen as being very similar concepts. Okay, thanks for watching as always, and I'll see you next time.